Okay, welcome back, everyone. It's week 2, day 1 of Web Fundamentals. We are going to start our morning algorithm, and I want to let you guys know to keep this, share the answer, the solution amongst yourselves, because we're going to keep this algorithm solution that we're going to find. We're going to work on it in this afternoon's demo. So far we've been doing a couple demos in the afternoon. We did one on Tuesday and then Wednesday. Today we're going to do one. Keep the solution to the morning algorithm. We're going to need that. Okay, so let's go over what it is. I'm going to take a look here at what it is. Before we get to the final solution here, we want to take a look at the math library. Let's remind ourselves what these do. Okay. So here I have a variable called var floor, and I say it equals math.floor, and it's going to math.floor 1.8. So who can tell me what this should console if I were to print this? So here, math.floor, what should this be?
1.8.
Okay. Where's my code runner? I have to run it this way. So I'm going to say node. CD2. Node script.js. Okay. So what this printed was a 1. Why? Why does math.floor print a 1?
So it rounds it down.
Right. Remember that math.floor brings whatever's after the decimal down to the floor. So no matter if it's 5 and above, we're not rounding it. We're just bringing it down to the floor, which would be 0, which would leave this to be 1.0, which is what we see here, 1. So we're bringing that 8 down to the floor, which is 0, which makes it to be 1.0, which is why we see 1 here. Okay, so this is math.floor. We need to be reminded of what this is and how it works in order to do today's algo. So we have math.floor, and let's take a look at math.ceiling. This time, inside of math.ceiling, we have math.pi. All right, so let's take a look at what math.pi is before we do anything else. Let's do that. All right, console.log math.pi. All right, so let's see what this is. I'm going to clear.
Right.
So this is going to print 3.141592. This is the number for pi. Okay, so if we console log pi by itself, we say math.pi. So how can we access pi? How can we access pi and also then apply math.ceil? Apply that to a variable, then console log that variable. So what do we get in this instance? What do you guys predict for this output here? This one is math.ceil on math.pi. So what does math.ceil do?
Round up.
Yep, that's the opposite of floor. So what do we see? What do we expect this to round up to?
I think 315.
Well, no, think
No?
it's after the decimal point, just after the decimal point. Just look at the first number. Ignore the
It's
rest.
going to be 3.
3.1. Just think of 3.1. What is 3.1? 0.1 going to what the ceiling is. What's the ceiling number?
4.
Right, exactly. It's going to go all the way up 1, 2, 3, 4, 5, 6, 7, 8, 9, and the ceiling would be making 3 go up to 4 and then being 0. So it will go to 4. Let's take a look at that. All right. So I'm going to console log that now, and there we get a 4. So math.ceiling is going to bring 3.1415. This large decimal number is just going to look and see what would be all the way to the ceiling? It would be to bring this 3-point decimal number to 4. All right, let's take a poll on how well we understand math.floor and math.ceiling. How well do we understand math.floor and math.ceiling? Okay, we've done this in programming basics. We can use this time to practice it a little bit more if we don't remember. Okay, you can try some different numbers. So let's look at another math.floor. Okay, math.floor, instead of 1.8, let's do 4 point this number. Okay, if I say math.floor to this, what should we expect as the output?
4.
Math.floor on 4 is 4. That was a mouthful. Here we are at 4 because it's going to bring it down to the floor. All right. And let's add another math.ceil just to make sure we understand this. Okay, I'm going to do 183 point this. Okay, what is that going to be? What's this number going to be if I say math.ceiling on it?
184.
Okay, exactly. Right, it's just going to look at the decimal number and say whatever you are, we're going to bring you up to the next one. What if we say 0 as a decimal number and we say math.ceil with this one? Let's take a look. So we're going to do 183.0 math.ceil on that. All right, we get 183. So it doesn't go anywhere if it's at 0. Okay, now let's look at math.random. Math.random. What does math.random do? Does anyone remember? Can anyone tell me?
I think it randomly throws a number out at you,
Right.
depending on what you're asking it to do.
Yes, let's just assign it to this variable, random, and console log it. So we're going to console log random when we assign it to math.random. So let's take a look at what math.random does. I'm going to run, and my output, as you can see here, is 0.122741113. It's a big, large decimal random number. So I'm going to do it again, and now you see it's different. It's different, a different decimal number. So each time I do math.random, it's going to give me a random decimal number, as you see here. Okay, so that's how math.random works. How can I make this to be a whole number? Can anyone tell me an idea of how to do this? How can I make this a whole number? Let's try something. Let's multiply it by a number. Okay, whatever math.random is, we're going to multiply it by 3 and then console log that. Okay, so now we have a random number. We've multiplied it by 3, and now it's above the 0, right? So how can we use random with one of these here now in order to get a number that's not a decimal number, but still random, right? Because now if I hit, if I console log, I'll get any number, 1.5, 2.0, 0.7. So what's my range here? What's my range look like of random numbers? Where
between 0 and 1.
Okay, so but this one went to 2.09.
Oh, sorry. Yeah, my bad. I forgot that you times it by 3, so it'd be 0 to 3. I mean, if you wanted like a number between 0 and 10, couldn't you times it by 10 and then round it?
Okay, yeah, exactly. Let's try that. Okay, let's multiply it by 10.
So this should give us a number between like 0 and 10 each time.
Okay, here we are. All right, and now we're going up to 8.5 something, 6.0. We have different random numbers, as we can see here. And we wanted to, what did you say, Richard?
We could round it.
Round it, okay.
Yeah.
We
So
can round it.
math dot round.
We can also use one of these, right? One of
Sure.
these we introduce. So let's try one of those before rounding, right? So how can we apply either floor or ceiling to this random? That's what I want you guys to figure out, okay? I want you guys to figure that out during your algo session with each other. And that's going to be the first function that you build, dice roller. You're going to build a function that you can, whenever you run it, give you a dice roll value. Okay, so I went over, I almost led you to the complete answer for this one. So I want you guys to figure out how to make this dice roller work, right? You're going to roll a number between 1 and 6. And then you're going to want to console log that number every time you roll it. Now, when you finish this dice roller, it's going to be a very similar solution to this final one. Now, the final one here, the one you're going to keep the code for this afternoon's demo, is going to be to use this array, right? Life's answers, right? It's just a bunch of different random answers. It is certain, it's decidedly so. So lots of different answers. Write a function that will pick a random answer out of this array. Okay, so you have a bunch of different array values. How can we then select a random answer out of this array? It's going to be a very similar process to how we did this. The only difference is now it's an array. Instead of a number, a definite number, 1 through 6, you're choosing through this array, okay? It's going to be very easy once you complete this. All you have to do is switch your mind to thinking about how can I access values in an array, right? We know how to do that. There's a specific way an array works that we can use. Okay, and with that, I think we are good to break out in groups. Anyone have any questions about what we're doing today? We're doing 2 algorithms. First one is going to be the dice roller. Once you finish that, you're going to move on to consulting the oracle. Here, you're going to select a random answer, create a function that selects a random answer out of this array. Okay, do we all understand what the objective is? Cool. All right, then. Let's go ahead and break out into groups. Welcome back, everyone. Okay, let's present our solutions. So who would like to present for the first one, which is dice roller? Someone present for dice roller, then we'll move to one more group for consult the oracle. So who'd like to present for dice roller?
Sure, I can.
Okay, thank you.
Am I sharing my screen? Yeah, I am. Okay, cool. That's weird. You guys can see my screen, right?
Yep.
Okay, so I'm not seeing like the green outline that I'm used to. All right, so we did math random, right? Which I'm pretty sure that was already in the code, right?
Mhm.
Yep, whoops, it is. Okay. So then we took that roll and we times it by itself. We took that roll and times it by 5. And that would have given us a number between 0 and 5, and then we added 1 to that because we always wanted to have it between 1 and 6. We never wanted to have 0 because, as far as I know, there's no 6-sided dice or 6-sided die with a 0 on it. So we want to make sure we always had between 1 and 6. And then we rounded it, so we always got the number between 1 and 6. We returned that 1 through 6, and then we just said, hey, well, once again, this is the code that was supplied to us. Hey, the player rolled between the 1 and 6.
Okay.
Run that a few times.
All right. So we have a player rolled a 3, 6, 4, 3, 5, 3. Okay.
If I do this enough time, we should see a 1. Oh, come on. We'll say I feel like I'm seeing too many 2s.
You're just an unlucky roller, maybe.
Yeah, you're just dealing with probability.
There
we
we
go,
go.
there we go.
Hey.
All right, let me ask you this. On line 5, you said roll equals 5, the roll equals roll times 5 plus 1. What
Yes.
if we were to change it to just plus 6? Will we get something different?
So you could potentially, so technically your roll could be this, right? 0.00001. So if we just did times 6 and then rounded it, we would get 0 still.
Okay.
So I
But
wanna do
rounding,
times-
that's the other thing about it. You can round and you won't know if it will round up or down based on that random number. You can use seal to consistently make it go
okay.
up. So you can multiply it by 6 and use seal.
Or you can use floor to
That's
make
true.
this one go down. Typically, when you're rounding in programming, you want to like decide which way you want to go and then adjust accordingly and kind of include like in your lot. I'd actually be interested in seeing a distribution map of this to see if it maps differently than ceiling or floor.
Okay.
Yep. And by the way, this is Lucky, everyone. I haven't introduced Lucky.
Hi, everybody.
He's our TA for the day. Kobe's out and sick. And so we have Lucky here, and he's going to be a great help for us today. So thank you, Lucky. Yes, that is true. So let's change it up. Let's change the roll to 6 and then use let's use seal to see how that works.
There's 1.
Group 5 was also using ceiling, and I think they had tried it both with ceiling and floor. So y'all's solution was right around on track. I think y'all were using ceiling but offsetting for floor in it.
Yeah.
So, Josh, can I ask a question?
Yes.
Would our code that we wrote before be wrong?
I don't remember what you wrote. Do you want to share your screen? Oh, you're in the same group.
Yeah, we're in
No,
the same
I mean,
group.
if it works, it works. It's technically, it's correct. It's technically correct. What we did here is just optimize it. Okay, instead of made it less complicated. Instead of making 5 plus 1, we just simplify it, make it 6, right? Instead of round, we make it seal so that we can use times 6.
I see. Okay, thank you.
Mm-hmm.
I'd say ironically enough, tip in programming, solutions being right or wrong isn't usually a binary thing. It has to do more with like, does it work consistently? And is it readable? Is it understandable by somebody reading it? Or like statistical probability when you're working with probability stuff, but it's mostly just like, can you predict and control input and output consistency? And is it readable for you or somebody else reading it and debugging it? And resilient enough to kind of take, errors that pop up along the way. There's usually a couple different ways of solving things like this.
I see. Okay, thank you so much,
Best
Lucky.
practices emerge from like people finding solutions that, fit any number of those kind of criteria or other criteria better. But the vaguer answer is like, if it works, it's a solution.
There we go. That's right. That is correct.
Being able to explain why you did it a certain way is usually more important than doing it the right way.
Okay.
All right. All right. Thank you, Richard's group. Appreciate you presenting that. Now let's move on to the most important one now. Now that we've got a grasp of how to do a dice roll. Let's see how we would consult the oracle. All right, so who'd like to present for this one? Consulting the oracle. Okay, I'm just going to throw a dart on my screen, and whoever it lands on, it's going to be Darius's group. Darius, does your group have this one? Consult the oracle. Okay, we're still on mute if we're talking. All right, we're going to move on to someone else's group. Eric, what group were you in? Did your group present already?
I was in Richard's group.
Okay.
I mean, we can go again if you want.
Whoever room 5 was, they had the other way of doing the random, and I think we're working on that array. I don't remember what y'all's names are. I'm still learning names.
Okay. Well, we want to have a group so for this random one, do you mean this consult the oracle one?
I guess I can show.
Okay, thank you, Christian.
I think this is right. So
Yeah, I mean, if it's not, we'll figure out what it is. It's not a contest. We're here to learn.
So like we just took what was in this one, which was math.4, math.random, multiplied by 6 plus 1, and then just shoved it in here, and then I just wrapped it in all this other stuff.
Okay.
And then it gives me outcomes, and then I'm hoping that it works.
Okay. The only difference now is that
Excuse
you
me.
use the array.length, right? You use life's
Mhm.
answers.length. So that essentially is the only difference between this one and the previous one. Now we're accessing values in an array. And so we have to access the array's value. So that's how here in life's answers, the bracket here, this is saying, give me the value, the number value at this array. So whatever number that we get from doing math.floor on math.random on life's answers.length plus 1, because this is a number, right? What number is this? How many values? Between 14 and 33. It's more than 15 values, probably around 1, 2, 3. I'm not going to count them, but we have the answers.length.
That's why I put answers.length. Is like I'm not counting those.
Exactly. We don't need to count it. We don't need to count it. The computer
Not
can
only
count it
not
for
only
us.
do you not have to count it, but that allows you a level of flexibility that if you pass in a different kind of array that is, half as long or twice as long or 100 times as long, it'll still work without changing the code. That's the future-proofing resiliency.
Exactly.
So,
Yep. We don't need to constantly count our arrays. We use the dot length and that will do it for us. So then let's run this function. Let's see what we get as a result. Okay.
Oh, and undefined ones.
Okay, so is this like a list of all your, let's clear this screen. Can we clear this and then run it from the start? Okay. Okay, so we're getting Outlook good. So we're getting some values here, all right? So let's run it a couple more times. Let's see if we're getting any undefineds. We want to check to see that we're hitting within the range of our array. So we got an undefined there. How did we get that? So we're checking within life's answers.length and we're saying +1. +1. So what is that +1 adding? It's adding a number to the length. And we're using math.floor on a, so what we want to do is not hit that undefined. We want to know where is that undefined. Is it outside of the array here at the end? Or is it outside of the array because it was looking for a value at the very beginning, like below 0? So I don't think we have an answer that's going to be less than 0 here, right? Because we're going to do math.floor on a random number that we're adding from life's answers.length +1. So I think what we need to do is remove that +1. So let's do that. Yeah, you're bringing up the dice roll, and sometimes it will go to a number that's outside of the array. So it's trying to access an undefined value that's outside of the array. So now let's run.
What I mean by that is, we were talking about because it gives some solutions on the documentation, including an inclusive and non-inclusive answer. This is where you need to be aware of your mins and maxes, because with your dice roll, you're working with math.random, which gives you a number, a floating point number between 0 and 1. It's non-inclusive of the high. So in order, you needed that +1 in your dice roll
Mhm.
solution, because you were basically getting a number between 0 and 5, but a dice can't have 0. So you were offsetting it again inside the math.random, or after, yeah, you were offsetting it up 1 so that you could floor it. But for this one, you have the length, which is, say if it was a 6-sided
Oh.
array, you're never going to need 6 like you did on the dice, but you are going to need 0. So you
That
don't
makes
need that
sense because it's
that
an
plus
array.
1. Yeah, in that formula that it gives you, that it shows in the documentation, if you want to check it out later, it talks about the min and max. In this case, the min is 0, whereas in the dice roll, the min was 1.
That makes
Yes.
sense.
Yes, excellent. Well said, Lucky. So let me just reiterate it in different words in case some of you didn't get it. All right. So the difference between this one and the dice roll is that we added a number to get a value from 1 to 6. So we could not get 0 as a dice roll value, right? Because that's not going to be an actual number when we would roll a dice. We would see a 1 through 6. In this case, though, our array starts from 0. So we don't want to add +1, because if we math.floor and our value goes to a 0 value, then we're going to add 1 to it and always get a value above 0, starting from 1 to a number that's outside of the array that sometimes we'll reach and get an undefined value, as we saw printed below. Okay, so let's if your group has not solved for this one, what you're going to want to do is, after this next lecture, group up and find the solution for this one, because we're going to need it for this afternoon's demo. So get the answers to this one. I'm going to post our morning algorithm lecture in our calendar in the YouTube playlist as soon as possible after I'm done with the lecture, so you guys can access that. But we definitely need the solution for this afternoon's demo. So get a hold of it from your group partners. Finish it if you haven't, but this is it right here. Okay. So does anyone have any questions about what we've done so far?
So is it fair to say that for the first one, you don't need 0, but for the second one you do? Is it
Right,
basically-
because for the
yeah.
first one, yeah, the dice roll values,
Okay.
we want 1 through 6. For this one, we are accessing an array value that starts from 0.
Mhm.
So that's why, yes.
Cool.
If you can correct me if I'm wrong on this, but when I was working with one of the groups, I told y'all to check the documentation. Anytime you're not sure how like a method or function works, check the documentation. The documentation for math.random actually does include the solution for this. So that was, I know one group mentioned that they had checked it, but then we're trying not to like use that, just rip that directly. Reading the two that it shows and understanding what each is doing, because that's like I said, it mentions one that is getting an integer, which is why you use the floor ceiling. Getting an integer between a range. One is inclusive of the higher range and one is not. The
Yes.
one that's not is the one you would want to use for arrays like this. And the
Yes.
one that is ones that you would want to use if you're doing something like a dice roll.
Yes.
I do a lot with this. I would almost play with both if you guys are going to be trying to look at that and understand the difference. Random numbers are one of those like programming, tools that like everybody uses decently or with a reasonable frequency, but not everybody really clearly understands it. So like being able to reference, understand, just kind of play around with it with different ranges and stuff like that to kind of get a feel for what it's doing. So that when you need it, you're always going to be able to go reference that if you guys need to write a random function. You can always go check the documentation, but just kind of like when you see something new like that and you're not quite sure with it, and read through some of the other ones too, because it'll tell you different kind of use cases
Yeah.
for where you might need random to use random as a seed tool to create other random types of things. So if you're like shuffling cards or something, you're always going to use math.random as a seed. So read through the documentation it'll help with that. And then just kind of play with the solutions and, get a feel for what it's doing.
Yep. In fact, we have a minute to spare to do that now. So Christian, would you share your screen again? So let's
This
take a look
formula
at,
for numbers between ranges is something that's taught. Like I mentioned in one of the groups, I was an engineering major for a little bit. I was a comp sci major. And we talk a lot about this in our engineering classes. This is a very common like formula to know for working with, regardless of what language you're working with. This is a pretty common way of leaning to like random number generators and stuff.
okay. So to give a clue, a little bit more context to what Lucky was just saying, we could use, for example, how would we use math.ceiling in this case and still get the same result? So instead of math.floor, how could we use math.ceiling? This would make our 0 values go up to 1. So then we would need to then subtract, right?
Mhm.
So we can use it then -1 here. Use dot seal.
Oh, wait, do you put that inside the parentheses or outside?
Yeah,
the
just like
parentheses?
that. Just like
Okay.
that.
I guess it's just the same thing as the other one.
Yeah, it's the same
Yeah.
exact thing. Yeah. Did we get an undefined value as our first one?
Oh, I didn't run it, sorry.
Okay. All right, so it's running. And no undefines, as you can see. Okay.
Another a good use case to consider too is if you needed a number between a range like 55 to 60, where you had a flat where a low end that was higher than what 0 or 1 or something like that, and how that would change that. That might help too with that formula, making a little more sense.
Yep. So we'll have a bit more opportunity to play with this afternoon. Okay. Again, like I said, share this code solution amongst your group. Don't let just one person in your group have the code. Share it before this afternoon's demo. Okay. We'll have some time to reconvene after this next lecture. Okay. So what we'll do is we'll go ahead and end this algo session now since we're running low on time. And so let me stop the recording. Christian, you can stop sharing your screen. Okay, so, all right, we're gonna take a break. I'm gonna start a timer so we can see that. Let me share my screen for that.
Now, I can do a quick little demo during the break for anybody who wants to hang out for some of this and how it works. Random numbers and stuff like that is one of my I love doing that in coding. I've done a lot of like algos and scripts that have that. So if y'all want, I can give y'all a quick little demo. Kind of walking through it if y'all want.
Okay, cool. We can do that while optional demo in the break. We also can visit Lucky in his office after the next lecture. Okay, so let me stop the recording and we'll go ahead and do that. All right, I'm going to share my screen. Timer is going to be set for 10 minutes, and then we'll start our next lecture on JavaScript objects in the DOM. So continuing on what Narciso started. So, all right, the timer started. I'll see you guys.
Does anyone want to hang out for an optional demo?
I'd be down. I mean, I'll watch if if you just want to mess around or something. I'm not gonna say no, you know.
Yeah, no, I get that. I like to do stuff like this because y'all don't get a lot of theory and like background and deeper kind of programmatic logic stuff very often. So I like to do that if it helps. So here, let me share my screen real quick. And I'll show y'all a fun one that I used this in a little while ago. Okay, so like what I was mentioning to y'all, y'all in programming, y'all very rarely have to write stuff from scratch. There's gonna be times when you're like doing tech interviews and stuff, where you're going to, want to like kind of have a, if you've worked up a decent proficiency, you'll have built-ins and stuff that you know how to use, just from experience. But if you're doing like anytime you're doing assignments on the exam, stuff like that, that's why we say it's open internet, open notes, open learn platform, everything. Because what you're doing as a programmer has a lot more to do with knowing how to put these things together, not being able to rote memorize all the stuff you need to use. And you'll introduce errors if you're always working from memory. If you're ever not sure, look up the documentation. So all I did for this in learning to use documentation is a super helpful thing. So I just looked up math.random.js. Mozilla is the ones who, own and manage JavaScript. So their documentation is usually pretty good. So what this tells you, it returns a floating point number between 0 and 1, non-inclusive, exclusive of the 1, meaning that it's always going to be 0. It can be 0 or 0.9999. And it's usually going to be a something dot something. So just to get a number like this, I'll work through.
Oh man, you got all the answers, huh?
Oh yeah, this is. I've been doing this for about a year and a half, so this is a lot of stuff. I also genuinely enjoy algos, so like, so let's see. I'm gonna do this in a way to. I'm gonna do this a little more complicated way, but I'll walk you all through way. So I'm gonna say, let's see. Say 20 for now. I'm gonna do a quick for loop and then use it inside of a for loop so we can generate like a array of numbers so it shows a little more. So I'm just gonna say, just to show you all that, what this does. Push. I'm gonna have it go over about 20 times and then populate numbers inside of this. Now I'll say console log results. So if I run that. So this is what the numbers look like themselves, right? So I have, 0.6 here, 0.2 here. So let's see. The next part of this documentation says getting a random number between 0 and 1 exclusive. So that's just straight up using math.random. Getting a number between two values. So this is where you come in with if I want, say, 0 to 20, let's see. So if I say pull this out here so that we can see the formula a little cleaner. Here. Don't worry about the constant let and stuff. Y'all get into that later. So I can multiply this by a number, right? So say I want numbers between 0 and 10. I can do that, run that. And now I end up with, let's see, here's a 9 here. There's a 1 there, 4 there, and it has like this extra bit, right? So if I was going to ceiling it, these would all go up to 6. This would go up to 7. This would go up to 8. Anything over the number is going to go up, right? So if I wrap all of this around and say math.ceiling, so let's see. So this is if I want number between 0 and 10, right? I never get a 10, but I do get 0-ish numbers, and on a it is possible to get 0.00. The reason you have this min because let's see. So we're gonna write these out a little more explicitly so y'all can see. So I'm say const max equals 10. Const equals, we'll say 0 for now. So to fill in this formula and kind of explain what it's doing. So right now, this is going to generate a number between 0 and 1. That's fractional, right? I'm going to multiply that straight by 10, and whatever I get is what I get. If I need if I need a number between not 0 and 10, but say like 5 and 10, right? That like, okay, I could just take this and say, okay, this is going to generate some number between 0 and 10. And if I need that, the minimum of that number to be 5, I could just push this up, right? And just say plus 5, except that creates a problem, right? Does anyone know what the problem is?
It raises your max.
Exactly. And so if I'm working with, and this is kind of where it shifts into programmatic logic. If I want to make this in a way that it's arbitrary, and I can say, okay, well, I know I have a min and I have a max, and I don't want to have to do the calculation in my head. That's why we have this bit of the formula here, which is saying, hey, this is going to need to raise the floor of the number results that you get. So if you need, 5 and 10 or 1 and 6, stuff like that, when you're using dice, push that number up, but at the same time, we need to be pulling that number back down inside the range that we're actually feeding to that. Because if we do this, you guys are exactly right. You end up with, there's no number below 5, but we do have numbers above 10, and we don't want that. So we need to then subtract that from here. So really what we're getting is a range of 0 to 5, and then we're offsetting that by 5, so that what that gives us is our target range. And so we could change that out with the variables. So we have max minus min. Right. So this part raises the floor. This part tells us the actual random part of the number. Because if you have numbers between 5 and 10, right? You know that those first 5 are just given. You're not going, it's 5 to 10 is no different than getting a range 0 to 5, right? It's just that you're adding that base number to it. So really, this part is saying you're trying to get a random number between 0 and 5. That's like the idea. You can use the same thing for the dice roll, right? Because this could also be max is 6, min is 1. Or if you're a real nerd like me, 12 or 8 or 20. Here we go. So that is between two numbers where these are still floating point numbers, right? This is where we get into the rounding part and why we use that. So getting a random integer, and that's kind of keyword in programming for whole number, not floating point number. We do the same thing. This is the same formula as above, except they use math.floor with it, right? And like I said, you can adjust this for ceiling if you prefer to use ceiling. This is typically the one that you'll see. These are just making sure that the numbers coming in are, this is basically scrubbing the input to make sure that the input is an integer as well, because it complicates it if not. Yeah, so you have the math floor here, which is going to bring that number down all the time. So let's see, if I have 6 to 1 and I wrap this in a math.floor. And you don't have to have as many parentheses as I do in this. This is mostly just to help segment like which part of the code is active in order of operation. So if I run this, now I have these here. Yep, so we have 1 to 5 because this is now, it's taking that range we had, which is like, it's the same as 0 to 5, offsetting it up by 1. And then we're rounding it down to cut off, to basically truncate all of these extra points that we didn't need. We're just saying, hey, ignore everything there. Ignore everything there. That's another term you'll hear for that is truncating. Just cut everything off. It's not the integer, right? Now we need to kind of offset that again because we need to say, okay, let's see, random integer between two values, but 0 to 1 is still exclusive of the max. So say this returns a random integer between the specified values. The value is no lower than the min, meaning it includes it, but is not equal to the max, meaning so that's exclusive. If you want it to be inclusive, you have to add that one. This one, and that's why I wanted to do it with different ranges, because in the dice roll one, that can be a little confusing. This one is not offsetting for that. This one is offsetting for the fact that you're flooring it. Because you're pushing that up, where you could, like I said, you could rework it to have ceiling, but this is like modifying the logic you were using before for a different use case to come into this, as opposed to like rewriting the logic entirely or going at it from like a different angle. So then if you say +1, so that's how you get the ranges with 1, because this is now 5 +1, so it's 6 but floored. So this is going to give you a number between 0 and 5.99, pulled down to 0 to 5, and then raised by your min, which is that 1, which is why you're going to get that. So just kind of like understanding how this is working like in chunks is, and working it up like that to where you're building on it and can kind of see the difference is helpful for understanding this kind of stuff. If you want to like get a quick look at a real random one, anybody here play D&D? This is an algorithm I wrote to determine how useful advantage and disadvantage is in D&D. Build a chart.
That's cool. Oh,
It
that's
builds
really
this chart, which is saying that if your percent chance of success rolling with disadvantage and with a straight roll at advantage or disadvantage for whatever DC threshold that you're trying to hit. It was a fun little project that I did a while back.
Wow.
I enjoy algorithms. But yeah, hopefully that helps. Like I know, like I said, random numbers are a little bit tricky to wrap your head around when you're first starting to work with them. So playing with them like that helps, start to kind of understand it. But hopefully
Awesome.
that helps.
Thank you, Lucky. And by the way, I didn't stop the recording. That whole section was recorded, so you guys can revisit that. So thank you again, Lucky.